When you're running large language models on your own hardware, there's a trade-off you learn to accept. Faster models tend to be dumber. Smarter models tend to be slower. You pick your poison and live with it. But every once in a while, a model breaks that rule. Today, we're putting that claim to the test. We're comparing two of the most talked about local LLM contenders, Qwen 3.6 at 27 billion parameters and Google's Gemma 4 at 31 billion, both at IQ4 NL quantization. The sweet spot where you get near full quality without blowing up your video memory. Both pushing a 32,000 token context window. Which one actually delivers where it counts? Our test bench is a Ryzen 7800 X3D with an RTX 4070 Ti Super. Both models ran through llama.cpp with flash attention and Q80KV cache quantization. Identical settings, 10 prompts from 30 tokens to 25,000, generating 256 tokens each. Let's start with speed, because this is what you feel every time you hit enter. Qwen averages 8.59 tokens per second. Gemma sits at 5.97. That's a 44% gap, and it widens with context. At short prompts, Qwen is 43% faster. Push past 5,000 tokens, and the gap hits 54%. At 25,000 tokens, a realistic long coding session or document Q&A. Qwen is still at 5.73 tokens per second, while Gemma drops to 3.35. That's barely above conversational threshold. Prompt processing shows the same story. Qwen is 27% faster on average, and at full context, it hits 752 tokens per second versus Gemma's 560. Now here's the counterintuitive part. You'd expect the faster model to use more video memory, right? Qwen uses less, 12,028 megabytes versus 12,418. But the real story is layers. Qwen offloads 44 of its 65 layers to the GPU, nearly 68%. Gemma manages only 35 of its 61 layers, just 57%. Qwen fits 9 more layers on the GPU while using less VRAM. The math. Qwen's layers are thinner. 27 billion parameters across 64 layers versus 30.7 billion across 60. Each Qwen layer costs about 273 megabytes. Each Gemma layer costs 355. A 30% efficiency advantage straight from architecture. Let's talk capabilities. We pulled intelligence scores from the official Hugging Face model cards. Starting with agentic coding, the gap is enormous. Qwen hits 77.2 on SWE-bench verified, within striking distance of Claude 4.5 Opus, a frontier model that costs orders of magnitude more. Gemma scores 52 on NL2 repo for repository level coding. Qwen more than doubles Gemma, 36.2 versus 15.5. Across SkillsBench, Claw Eval, and Terminal Bench, Qwen leads by 15 to 25 points. If you're building a local coding agent, this is not a contest. On knowledge, they're genuinely competitive. MMLU-Pro shows Qwen at 86.2 to Gemma's 85.2. MMLU Redux is a virtual tie at 93.5 versus 93.7. Gemma's only lead in the entire comparison by 0.2 of a point. On C-eval for Chinese language knowledge, Qwen pulls ahead at 91.4 to 82.6. STEM reasoning is all Qwen. GPQA Diamond, HMMT Competition Math, AIME 2026, the International Math Olympiad Answer Benchmark. Qwen leads by 3 to 7 points across the board, with the largest gaps on the hardest tests. On Humanities' last exam, both score low since these aren't frontier models, but Qwen's 24 to Gemma's 19.5 is still meaningful. Vision shows the widest disparity. Qwen leads MMLU, MathVista, Real World QA, and OCR-bench by 2 to 12 points. Then there's RefSpatialBench, testing spatial reference understanding. Qwen scores 70, Gemma scores 4.7, a 65-point gap. The one vision benchmark where Gemma edges ahead is MMLU-Pro, 76.9 to 75.8, a single point. Why does Qwen pull so far ahead? It's attention architecture. Qwen uses gated delta-net, a form of linear attention that scales gracefully with context length. Gemma uses interleaved sliding window and global attention. Sliding window works at moderate lengths, but as the KV cache grows past 10 or 15,000 tokens, the overhead hurts. DeltaNet's linear complexity means the performance hit is fundamentally smaller. Qwen degrades 29% from short to long prompts. Gemma degrades 38%. That architectural difference cascades into every measure: generation speed, prompt processing, and memory efficiency. One more thing. During our benchmarks, Gemma benefited from KV cache reuse on 5 of its 10 prompts. It had already processed part of the prompt and didn't do the full work. Qwen had 0 cache hits. Even with that structural advantage, Gemma still came out significantly slower. In normal use, without carefully primed caches, the real-world gap would be even wider. The bottom line, Qwen 3.6 27B at IQ4NL is faster, uses less video memory, fits more layers on the GPU, scales better to long context, and delivers more capable intelligence across coding, math, and vision, while being 3.7 billion parameters smaller. Gemma 431 billion is competent. It's competitive on knowledge recall, but on the hardware most of us actually have, at the quantization most of us actually use, Qwen is objectively the better choice. If you're setting up a local rig and deciding between these two, the data points one direction. Try Qwen 3.6 at IQ4 NL. See how it handles your workloads. And if you've been running Gemma 4, it might be time for a switch. Thanks for watching, and we'll see you in the next one.